Now, in our next problem, or set of problems, we're going to use this sequence. We're told the sequence, 1, 10, 19, 28. I want to find the common difference. So to find my common difference, first thing I'm going to do, d then is 10 minus 1, which is 9. That's my common difference. Now I want to write my equation. Well, in order to write my equation, I know my first term is 1. My second term is 2, my third term is 3, and so on. I want to find the 0th term. So what's the 0th term? Well, what I'm going to do is I'm going to take my first term, which is 1, and I'm going to subtract my common difference. Common difference being 9. So my actual sequence starts at -8. So my equation then, if we want to write it like we did with slope-intercept form, usually we'd write y equals mx plus b. Well, y equals your slope. What are we changing by? That's our common difference, isn't it? 9x minus 8. That's our equation. Now, the difference here is when we were doing functions or lines, your domain were all real numbers. But in a sequence, your domain is not all real numbers. They're integers. So rather than using y and x, we usually use like n. So I'm going to say, in function notation, t of n equals 9n minus 8. N means number. Now, if I want to take a look at example 6, I want to find the 12th term in the sequence. I'm going to replace x, or n, depending how you look at it, as 12. In other words, I'm going to take 9 times 12 minus 8. Well, 9 times 12, let me see, 9 times 2 is 18. So you get 108 minus 8. So the 12th term of our sequence is 100. I want to graph the first 5 terms of my sequence. Well, I know my 0th term is -8, but I don't have that option. So I'm going to go 1, 2, 3, 4. Well, what comes after 28? I think I'm going to make my table over here. So I have n and t of n. So my first term is 1. My second term is 10. My third term is 19. My fourth term is 28. So my fifth term, 28 plus 9 would be 37. So I want to go up to 37 on my graph. And if we count here, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 37 divided by 10 is 3.7. So if I wanted to count exactly by 3.7, I'd get to the top. Well, I'm going to round that up to a nice number that's easy to count by. Let's count by 5s. So here's 5, 10, 15, 20, 25, 30, 35, and 40. And I know my last term is 37, so I'm not going to worry too much about that. And then I'm going to put my first 5 terms here on my x-axis. So we know when you're at 1, we're starting at 9. 2 is going to be 10. Whoops, I did that wrong. 1 is 1, isn't it? Sorry about that. First term is 1. The second term is 10. My third term is 19. My fourth term is 28. And my fifth term is 37. Now we're not going to connect these because we don't have a 1.5 term. Now let's take a look at example 8 here. On example 8, I want to know which term in the sequence is 172. In other words, I know the term. The term is 172. Equals to, I'll go 9n minus 8. And let's solve that equation. We're going to add 8 to both sides. So 172 plus 8 is 180. Divide by 9. And you get 20. So this would be the 20th term of the sequence. If you would do I want you to understand, not every number is in that sequence. So if you would solve this and n turns out to be a decimal, that number would not be in the sequence. So for example, if I said which term of the sequence is 173, you would solve that equation, you get a decimal, and if you get a decimal, that's not part of your domain. So hey, you'd say, hey, there is no term that has that value in this sequence. Luckily for us, 172 did.